We are always privileged to have you at Medical Sciences by Naphtali Muhumuza. And today's session we want to look at SALHS method, but majorly we want to look at determination or preparation of 0.1 normal hydrochloric acid used in SALHS method. SALHS method is one of the oldest methods that were being used to determine HB in the laboratory, what we call hemoglobin concentration. And this was one of the visual comparative method where we use a SALHS apparatus. So we want to see how can we prepare 0.1 normal sulfuric acid, hydrochloric acid, or we can call it 0.1 molar. Hydrochloric acid being a monobasic acid, having the valence, it is monovalent. So normality is always the same as molarity because it is a monovalent acid. So we want to look at how can we determine, how can we prepare, and our question is asking us to prepare 500 mils. Want to prepare 500 mils of 0.1 normal hydrochloric acid from the stock solution. This stock solution comes in the brown label, in the brown bottle, having a label whereby a label says the percentage purity is 37% and the specific gravity is 1.189. And as we usually always remind you to subscribe if you haven't, like the video to always energize us to make more, and share the comments. So on preparation, that we can always use this label on the bottle to prepare 0.1 normal or molar hydrochloric acid for our SALHS method, whereby the principle of SALHS states that when well-mixed EDTA blood is mixed with 0.1 normal hydrochloric acid in a ratio of 1 in 200, we see the hydrochloric acid oxidizing the hemoglobin in red cells to form acid hematine. And this acid hematine is a brown color, which is the one that we compare with the color standard. And we get HB in grams per liter. So on the preparation of 0.1 normal, we shall always start with interpreting what 37% mean. And 37% means 37 grams of HCl dissolved in 100 mils. Dissolved in 100 mils of distilled water. That is what means 37% purity. So we start by interpreting what 37% mean, and after knowing what 37% mean, we are going to be required to see if 100, so we shall say if 100 mils of D water dissolves 37 grams of HCl, we want to see how much are dissolved in 1 liter, because molarity or normality is always in 1 liter. So what about 1,000 mils, which is 1 liter of distilled water, will dissolve? We cross multiply, whereby we're going to get 1,000, we multiply by 37,000 mils, times 37 grams, we divide by 100 mils. That is cross multiplying, and we're going to see getting 370 grams. And these grams are in a liter. These grams are in a liter. And these grams are of HCl in a liter of a solution. Why are we labeling to know how many grams are dissolved in a liter? Is we need to determine molarity. And we know that after getting the grams in a liter, we see normality, or what you call molarity. You can call it molarity stroke normality, whereby normality is the equivalent weight of solutes in a solution. And we said because hydrochloric acid is a monovalent acid, normality is the same as molarity, which is got by getting mass in grams per liter. You multiply by the specific gravity on the label, then you divide by relative molecular mass of hydrochloric acid, since we are given hydrochloric acid. So we see we have already mass in grams per liter. We already have specific gravity as 1.189. So what we don't have is the RMM of hydrochloric acid, whereby relative molecular mass of hydrochloric acid is the same as hydrogen has atomic number of 1 times 1. Then we add chloride, which has atomic number of 35.5, but is 1. We multiply by 1, and we get 36.5. That is the relative molecular mass of hydrochloric acid. So after getting relative molecular mass of hydrochloric acid, we have the mass in grams per liter, and we have the specific gravity. We substitute in the formula, whereby normality or molarity is going to be 370 grams per liter times 1.189. Then we divide by 36.5. And this one, when we compute using our calculators, we're going to compute together. When we get 370, we multiply by the specific gravity, which is 1.189. We are able to get 439.9. Then we divide this answer by 36.5, and we are getting 12.053. It is giving us 12.053 normal, or we can say molar. Why are we saying normality or molar? We say the monobasic acids, because they have a monovalent, since the valence is 1, normality is always the same as normality. So this is the number of moles in this bottle, or this is the original concentration. So this one becomes the original concentration of the acid. So when we have the original concentration of the acid, and the question wants us to prepare 500 mils of 0.1 normal, meaning we have the required volume, the required concentration, which is 0.1 normal. We have the required volume, which is 500 mils. And we have the original concentration, which is 12, which we have got as 12.053 normal. So since we have the original, we have the required concentration and required volume, we can use RV over O equals to X, whereby X is equal to RV over O, where R is the required. You have to define this later. R is the required concentration, V is the required volume, then O is the original concentration, and X is the amount, or the volume of the original required to the reuse. So after knowing that we have all of this, we can substitute by saying our X, which is the volume we require to pipette from the original, equaling to R, which is 0.1 normal, times volume, which is 500 mils. Then we divide by original, which is 12.053. And we are able to get the number of mils. This is normal. So normality goes with normality. We remain with 0.1 multiplied by 500. 0.1 times 500, which is 50. Then we divide by 12.053. We get 4.5. 4.15, we are able to get 4.15 mils. So these are the mils which we shall use of the origin concentration. So shall pipette is 4.15 mils of 12.053 normal hydrochloric acid, and we shall top up. And the rule is always we add acid to water. We add acid to water. So what we need to know is we have to first calculate the amount of, so the volume of distilled water. The volume of distilled water, we shall get the total, which is 500 mils we need for the solution. We subtract 4.15 mils, and we are able to get, when we get 500 minus 4.15, we get 495.85 mils. So what we shall do is that we are going to first add we shall get our container. We will assemble our requirements, that is the tubes, the storage bottle, the measuring cylinder. Then we shall add 495.85 mils of distilled water into the storage bottle first. Then we slowly add the acid, because the rule says add acid to water slowly. We slowly add 4.15 mils of 12.053 normal hydrochloric acid, and after adding it there, slowly we mix the content. And after mixing the content in this tube, we stopper or we cover the tube. We mix and stopper or we cover the tube. After covering, we shall label. And labeling, there is much information we put on the label, whereby you indicate the concentration of the name and the concentration of the acid, which is 500 mils of 0.1 normal hydrochloric acid. That's how you label it, the concentration. You put the initials of the preparer. You put the initials of the preparer, the person who has prepared, and you add after here you add the date of preparation. Even you put the expiry date. Then you put the storage condition, whereby the storage condition is that you store in the dark, away from sunlight. And lastly, you can indicate precautions. And among the precautions, you put it is corrosive. This one is corrosive, meaning you don't hold it without protective gears in your hands, or sometimes you keep them out of reach of children because they can easily play with them. So this is the label, and always put it in details because each label takes a half a mark. And this question, once it is asked in your exams, this is how you can answer it, whereby we can begin by interpreting 37% purity, what it means. And after knowing it is dissolved in 100 mils of the water, we have to look for the grams that is dissolved in 1,000, because moles are always in 1,000. We get 370. Then we also get the relative molecular mass of hydrochloric acid, which is 36. Then we compute in the formula, which says molarity or normality, the same as mass in grams per deciliter. Mass must be in grams per liter, times the specific gravity divided by relative molecular mass. And from there, it helps us to know the original concentration, which we can feed in RV over O to get the required volume, which we can pipette from the original, which we have got. Then we are able to get the amount of the mils of the original. After getting it using RV over O, we begin the procedure where we assemble our requirements. Then we pipette or we measure 495, which we have subtracted using the rule adding acid to water, not water to the acid. So this is the procedure. Then we cover the container and label with these details. So this is what we are required of in case you are asked in an exam or you are in the laboratory and you want to prepare some amount of the acid you want to use to do SALHS method for HB determination. Thank you so much for being with us, and I can always give you the exercise so that you can always try it out in your free time. And after trying it out, sometimes you can share your answer with us to see or to comment if you have got the right one. This exercise we want to do in this session, we want you to describe how to prepare 200 mils of 0.1 normal hydrochloric acid, given that specific gravity is 1.189 and percentage purity is 40%. Percentage purity of hydrochloric acid is 40%. So this is the exercise I want you to try out to describe how to prepare 200 mils of 0.1 normal hydrochloric acid, given that the specific gravity on the label is 1.189 and the percentage purity is 40%. We shall be expecting answers in the comment section, and please keep active and let's learn together by sharing the knowledge. Thank you so much. Remember to subscribe if you haven't, like the video and share the comments. Thank you so much for listening.